Hey guys, I wanted to put this video together just in case we didn't get to examples 3 or example 4 in the notes today. Example 3 and example 4 pertain to solving quadratic inequalities. And if we look at example 3, we have to solve x squared minus x minus 12 greater than 0. And so I'm going to give you 5 steps, lay out 5 steps to follow in order to help you solve quadratic inequalities. So the first thing that you're going to do, so step 1, is going to you want to make sure that this is in standard form. So put in standard form. And if we look at this, it already is in standard form. So we're good to go. We can go to the next step, step 2. And step 2 is to solve for x squared minus x minus 12 equaling 0. So take the inequality and basically solve for the equation. We've learned that we can solve quadratics by factoring, by completing the square, by using the quadratic formula. I think the easiest thing to do here is just factor. So I'm going to write my parentheses, put x first, and then my signs here are negative, negative, so the signs of the factors are going to be negative, positive. And I'm looking for factors of negative 12 that sum to negative 1. So negative 4 and 3. Their product is negative 12. Their sum is negative 1, so we're good. And then I set both of these factors equal to 0 and solve. And I'm going to get my solutions. So my solutions are going to be x equaling 4 and x equaling negative 3. In step 3, I'm going to take those solutions, and we said that those solutions are x equals 4 and x equals negative 3, and you're going to sketch a graph. Alright, this does not have to be anything super accurate. What we want to see is, and what we want to determine is, does this graph open up or down? And then where does it intersect the x-axis? So it intersects the x-axis at the point of our solutions. So negative 3 and 4 is where this graph will intersect the x-axis. It's going to open up because my a is positive. So those are really only the two things that I'm really interested in here. In step 4, I'm going to shade. And what I'm going to shade is part of the graph that is the part of the graph of x squared minus x minus 12 that is greater than 0. So this is part of the graph that's greater than 0, and this is part of the graph that is greater than 0. I'm going to then write those solution sets in interval notation, so that's step 5. Alright, so the solution set to this inequality can be all real numbers from negative infinity to negative 3, and we're open on both of those because our sign is greater than. So it could be we could have a solution in that interval, or we can have a solution in the interval from 4 to positive infinity. I'm going to circle this, and this is my answer. That is my solution set to the quadratic inequality above. Okay, we're going to go ahead and go over example 4 now. This is a little bit more difficult of an inequality that we have to solve, but nonetheless, if we follow our 5 steps, we should be good. So step 1 is to put in standard form. Alright, this inequality is not in standard form, so we're going to have to move the 20 over. So we're going to have 2x squared plus 3x minus 20 is less than or equal to 0. Step 2 now, we want to solve for 2x squared plus 3x minus 20 equaling 0. So solve for the equation of this inequality, if you will. I'm going to rewrite this on the next slide, because this is we're gonna factor by grouping here, and we're gonna need some more room. So we have 2x squared plus 3x minus 20 is less than or equal to 0. Okay, when we factor by grouping, we are looking for factors of a times c that equal our b. So we are looking for factors of a times c. So a times c is negative 40. So we want factors of negative 40 that equal 3. So 8 and negative 5 are going to be those factors. And we're going to use these factors to rewrite this middle term here. So we're going to have 2x squared, and then we're going to write a positive 8x. I write 8x next instead of negative 5x because 8x goes better with the 2x. There's a common factor. And then I'm going to write minus 5x minus 20 equals 0. Alright, remember we're solving for the equation here, not the inequality, so we want to find the solutions. Now we're going to factor by grouping, so let's group these together. So we have 2x squared plus 8x. Put parentheses around the first two terms. Always put a plus sign here between, and then I have a negative 5x minus 20, and that equals 0. I now factor out the GCF. So I can factor out a 2x here, leaving me with x plus 8. I'm sorry, it's going to be x plus 4. And then I'm going to factor out a negative 5 here, so I'm left with x plus 4. If you do this right, what's in parentheses here should be the same. That's one of my factors. So x plus 4 is one of my factors, and then what's left is the other one of my factors. What I do now is set them both equal to 0. Oops. And solve for x. So x equals negative 4 and x equals 5/2. I'm now going to plot these solutions on the x axis. So 5/2 is 2.5. Come on. It's being difficult right now. There we go. And then I'm going to plot x equals negative 4. Alright. Our A is 2 and it's positive, so this is going to open up. This graph is going to open up, so it's going to look something like this. Alright, and so, so step 3 was to sketch graph, which we just did. step 4 is to shade the part of the graph, which is 2x squared plus 3x minus 20 less than or equal to 0. So we want to sketch the part of the graph here that is less than 0 now. So this is all the graph less than 0. Alright. And we want to write this now in interval notation. Alright, so our solution set is going to be the interval from -4, and we're closed on -4, to 5/2, and we're closed on 5/2 because we are less than or equal to. And so this is our final answer. So any x's in this interval here will satisfy this inequality. So that wraps up examples 3 and 4, and I hope you found this useful, guys.